Welcome everyone. Today we are doing a deep dive into Apache Kafka, covering both the theory behind why it exists and a hands-on demo you can run on your own machine with Docker. By the end, you will understand what Kafka is, how it works internally, and have a working local cluster you can experiment with. Here's the plan for today. We'll start with what Kafka actually is, then compare a system without and with Kafka, understanding the problem it solves. From there, we will go into the architecture, which will cover brokers, topics, partitions, and KRaft. Along with that, we'll cover key benefits that Kafka brings, including scalability and fault tolerance. We'll finish with a live demo where we spin up a Kafka in Docker and produce and consume real messages. Apache Kafka was originally built at LinkedIn around 2011 to handle their activity stream, things like page views, clicks, and feed updates at massive scale. It was open source and donated to Apache Software Foundation and is now used by over 80% plus of Fortune 100 companies. Think of it as a distributed commit log, an ordered, immutable sequence of events that multiple systems can read and write at their own pace. The three core capabilities of Kafka are publish subscribe, durable storage, and real time stream processing. Kafka is not just a message queue. The key differentiator is that events are stored and can be replayed. Now, let's look at a component of e-commerce application before Kafka. When a customer places an order, the order service often has to communicate directly with multiple downstream systems, including inventory, payment, notification service, and analytics service. This creates tight coupling, meaning the order service needs to know where all of the systems are and how to communicate with them. The more consumers we add, the more complex and fragile the system becomes. Now let's add Kafka into the architecture. Instead of communicating with every downstream system directly, the order service publishes a single event. For example, order created to Kafka. Any service interested in orders simply subscribes to the topic. Another advantage is resilience. If analytics goes down for an hour, Kafka retains the events. When analytics comes back online, it can continue processing from where it left off. Kafka also allows consumer to process data at their own speed while the producers continues to operate normally. In short, Kafka simplifies integration, improves reliability, and makes the system easier to scale as the organization grows. Now, let us look at the architecture that makes this all possible. At high level, Kafka sits between producers and consumers. Producers send events to Kafka, and consumers read those events from Kafka. The key advantage is that producers and consumers don't need to know about each other, they communicate through Kafka. Let's focus on how Kafka manages the messages. Here, Kafka Broker is essentially a Kafka server. The broker is responsible for organizing the messages into topics. You can think of a topic as a category of event, such as a video event. Each topic is divided into multiple partitions. Here, as you can see, for example, there are long videos and a partition with short videos. Partitions allow Kafka to store and process data in parallel, which is the foundation of Kafka's scalability. Since different partitions can be processed independently, it allows multiple consumers to work in parallel. Now let's see how multiple brokers or multiple Kafka brokers work together. Kafka cluster essentially consists of multiple Kafka brokers which stores partitions. To prevent data loss, as we can see, partitions are replicated across brokers. They are divided into leader partitions and replica partitions. If one of the broker fails, another replica automatically takes over, allowing Kafka to continue operating with minimal disruptions. Let's zoom out and see how the entire architecture works. On the left, we have producers. Producers are any applications that publish events. That can be your order service, payment service, IoT service. They write to a named topic inside Kafka cluster. Topics, as we saw before, are split into partitions. This is Kafka's unit of parallelism. Each broker in the cluster owns some partitions and stores the actual data on disk. The KRaft controller at the top is used to manage the cluster metadata. For example, which broker owns which partition and who the leaders are. On the right, we have consumers which subscribe to the topic and read the messages. At the bottom, you can see schema registry and Kafka Connect. Those are ecosystem tools for schema management and external integrations. Now let's move on to the demo with Docker. So this is the Docker Compose file that we will use to set up Kafka cluster on a local. As you can see, we are using Apache Kafka version 4 image to set up our Kafka cluster. The container name would be Kafka, and we have set the port to the default of 9092. In the environment, we are first setting the KRaft mode uh, by setting some environment variables. After that, we are configuring the listeners for both the client and the controller communication. This is used to internally by the Kafka to communicate between the processes. And finally, we are setting the replication factor of internal topics to 1. That means we will have only one broker and we will not have any replica partitions. So let's start by first initiating Kafka by running the Docker Compose. So it will be Docker push up and D. D for detach mode. So as we can see, we have started the container. Let's verify if our container is running by grabbing the cluster ID of the Kafka cluster. As we can see, it has returned the cluster ID. That means our container is running. Now let's create an event. We will call it name events in our Kafka. So we have created a topic called name events. Now let's have another terminal where we will create a producer and publish some names. So our publisher is set up. Now let's try publishing some names. First name would be Joy Almeida. Second name would be Violet. Now let's try and reading those messages through a consumer. So I am opening another terminal for consumer and let's paste this command which will read from the beginning from the name event topic. So let's start and let's wait till our consumer is set up. So as we can see, consumer is set up and it has read the messages that were published to the name events. Now let's try publishing one more name. Let's say for example, Jack. Let's see if the consumer has read it. Yes, the consumer has read our message correctly. So this brings us at the end of the practical. Now let's summarize what we just saw. So to summarize, Kafka is fundamentally different from a traditional message queue. It's a distributed, immutable event log that any number of consumers can read at their own pace and replay at any time. The producer consumer decoupling is its superpower for microservice architecture. Partitions and consumers groups give you the ability to scale both writes and reads horizontally. And as you have seen, you can have a production grade cluster running locally in under a minute with Docker. Thank you so much, and I'm happy to take any questions in the comments.